See this network problem. Here the question is determine the Norton equivalent circuit for the circuit shown in figure. So before solving, I'm just explaining the Norton circuit. So any network. So inside this we can see a two-terminal network A and B. Any two-terminal active linear bilateral network can be transformed to a simple circuit which contains a current source and a parallel resistance. That is any network. It must be active. Active means there must be active element like voltage source, current source. Like here in this circuit we have 6 ampere current source and 12 volt voltage source. Linear means it must follow the Ohm's law. Bilateral means we can change the terminal. So any two-terminal active linear bilateral network can be transformed which contain a current source and a parallel resistance. This is IN and this is RN or RTH. This one is the equivalent resistance of the network and this IN is the short circuit current. That is, if you short the terminal AB, then ISC is there. This is equal to IN. So anyhow, we have to solve this problem. So here we can see there are 4 resistances are there and one current source and one voltage source. And ultimately we need a circuit, Norton. This is called Norton equivalent circuit. This figure is Norton equivalent circuit. So we have to find out the RTH and IN both. So how to find out the RTH or RN? So what are the steps? Steps is replace voltage source by short circuit, replace current source by open circuit and look at the terminal point and find out the equivalent resistance. So we have to look at the terminal point. So we have to redraw that circuit. So these are the circuits. Now what to do? We have to find out the equivalent resistance of this network. So we will replace the voltage source by short circuit. So we will replace it by short circuit. That is, I will connect this one. Now we have to replace the current source by open circuit. So we will open it. And we have to look from the terminal, that is from AB. So how? We can see 10 ohms, 4 ohms and 10 ohms are in series and it is parallel to 6 ohm. So Rn is the equivalent resistance. This is equal to 10 plus 4 plus 10 parallel to 6 ohms. So how much it is? 24 parallel 6. So this is 24 into 6 divided by 24 plus 6, that is 30. So this is 5. So this is equal to 24 by 5 ohms. This is your equivalent resistance. This is actually how much? 4.24 by 5, so 4.8 ohm. Now we have to find out, next step is we have to find out the short circuit current. So what to do? We have to again redraw the circuit. Now here we have to redraw these circuits for finding the current. So here we can see one current source, this current is going upwards, and here it is voltage source and series resistance. So what we can do, we can convert this voltage source to equivalent current source. So now I am redrawing the circuits. This is 6 ampere. Here it is this current. If I convert this one in current source, so it will be 12 by 4, that is 12 by 4 ampere. So this is equal to 3 ampere. And this 4 ohms will be parallel to it. Now this is 4 ohms, this is 10 ohm. Again this is 10 ohm. And this is 6 ohm resistance. So what I can do, two current source in the same directions. So we can redraw the circuit as 3 plus 6. So this will be 9 ampere current source. And what are the resistances? This is 4 ohm, 4, 10, 10, and this is 6. Now look, again I will apply source transformations. This is one voltage current source and parallel resistance. So I can convert it to equivalent voltage source. This will be how much? This will be one voltage source of 9 into 4, that is 36 volt. And this 4 ohm will be in series. So this is 10 ohm. This is 10 ohm. And this is your 6 ohms. Now sum of this resistance, as this is open, no current will flow through this path. So 4 ohm, 10 ohm, 10 ohm, 10 ohm, 6 ohms. So what I can see, 10 plus 10 plus 6 plus 4, 30 ohms. So actually this is 30 ohm resistances. This is 30 ohm. So what will be the current? Current I is equal to voltage is 36 volt divided by 30 ohms. So this is your current. This is not short circuit current, but current for this source. Now what is the VTH? VTH is the drop through this 6 ohms. So VTH is equal to voltage drop across 6 ohms. So this is equal to 6 into, as this one is a series, so the same current will flow. So 6 into 36 by 30. So this one is 5. So 36 by 5. This is your VTH. Now, what will be the short circuit current? Short circuit current is equal to, now you have one voltage source. VTH is equal to 36 by 5 volt. And this resistance is what will be the equivalent resistance? Equivalent resistance is how much? Equivalent resistance is 24 by 5 ohms. See, this is your Thevenin's equivalent circuit, right? Now you have to convert it to Norton equivalent circuit. So ISC is equal to, you have to short it. So what will be the current? ISC is equal to IN. This is equal to 36 by 5 divided by 24 by 5. So 5 cancel. Now 36 by 24. So 12. So now it is 3 divided by 2. So this is 1.5 ampere. Now you draw the Norton equivalent circuit because you have ISC and RN both. So Norton, in the Norton equivalent circuit, this IN will be ISC. This is 1.5 ampere and the equivalent resistance RN is equal to 24 by 5. This is equal to 4.82 ohms. This is your desired answer. Thank you for watching.